about a year ago. And ever since we've changed it to this format of doing it this way, got a lot of good feedback from Chick Airman and the students, you know, new hires. So this is how I recommend you do it, okay? So you start off up here, again, you work your way across, talk about this, PSC light, and then you get to the flight control panel. Before you go into the panel, say, all right, before I talk about this panel here, I'd like to jump over here to our hydraulics, talk about the hydraulic system, and then I'll go back to the flight control panel. By doing that, you're laying down a lot of good foundation for that panel, okay? Knocking out the hydraulic systems, and it will prevent you from jumping around a bunch up there, okay? The biggest problems I've seen in the year and a half of teaching this is guys get up here and they start jumping around the panel, all right? Remember I was talking about compartmentalizing these panels? On this one, you have 9 different overviews and discussions on this one panel, okay? There's 1, there's 2, 3, 4, 5, 6, 7, 8, 9, okay? If you don't organize the discussion, you're going to start jumping around, it gets confusing, you get lost. It just makes it more difficult. So here's what you'll do, okay, ready? Are you recording this? All right, let me know how long this takes. Just go for it back here, okay? Come out here. All right, before I talk about the flight control panel, I want to jump over here, talk about hydraulics, okay? This airplane's got 3 hydraulic systems, System A, System B, and the standby hydraulic system. Each hydraulic system has its own reservoir located in the main wheel well. Each reservoir has standpipes feeding various components. Mr. Chick Airman, you want me to talk about those standpipes? No? Okay, cool. I'm going to keep going then. Just know that the standby hydraulic reservoir that gets fed and pressurized through the B system reservoir. Those reservoirs are pressurized through our auxiliary system, like we mentioned earlier. Actually, you probably wouldn't have gotten there yet. You're going this way. Those are the main wheel well. System A and B hydraulic systems are controlled down here with our switches here. Each A and B system have 2 pumps, an engine-driven pump, electric motor pump. Engine pumps have an on-off position for the switches. Those engine-driven pumps are actually mechanically connected to the engine accessory box. So anytime you have N2 rotation, those pumps are turning. When you move the switch to off, you're not turning the pump off, you're just blocking the fluid from leaving the engine-driven pump and entering the system. It just gets returned back to the reservoir. When you turn the pump on, it opens that blocking valve, allowing the pressure and fluid to leave the pump and enter the hydraulic system. Low pressure line above it just indicates low output pressure from the pump. Okay, normal output pressure for both electric and engine pumps, 3,000 psi. Which is a big difference here is the engine-driven pump puts out 6 times the volume of the electric motor pump. We have electric motor pumps for the system A and B. You'll notice they're labeled electric 2 and electric 1 because they're cross-wired. They're AC pumps, and they're powered by the opposite side's AC transfer bus. An on-off switch there because it is a electric motor, so that actually turns the motor on and off. Now, it is an electric motor. It's susceptible to heat, so it's lubricated and cooled with hydraulic fluid that passes through a heat exchanger in the respective wing tank. We have a limitation on the ground. We need to have at least 1,675 pounds of fuel in the respective wing tank in order to turn our electric pumps on. All right. Should that fluid or the pump itself get too hot, we'll have an overheat light up here. Low pressure light again just indicates low output pressure from that pump. All right. Those hydraulic systems power an array of systems on this aircraft. We'll kind of talk through some of those. We have a standby hydraulic system, and those indications are up here. We have a low quantity light indicating less than 50% of fluid in the standby reservoir. That light is always active. The light below, low pressure light, is only active when the system's active. And again, that just indicates low output pressure of the 1 electric pump we have from the standby system. And then our standby rotor on light indicates that our standby hydraulic system is powering our standby rotor PCU. That's all it means. That light will only come on when it's powering the standby rotor PCU. There are 3 ways in which you can manually activate the standby hydraulic system. That's putting either one of these flight control switches to standby rudder, activates the standby hydraulic system, or arming your ultimate flap system that will also activate your standby rudder. I'm sorry, your standby hydraulic system. Okay. 2 times in which that system will automatically activate. The force fight monitor will kick the standby hydraulic system on. Or if you're on the ground with wheel speed greater than 60 knots or airborne, your flight control switches are on, your flaps are not up, and you lose system A or B, then the hydraulic system will automatically activate in that scenario as well. Okay. Just real quick, I'll just go over the 4 things that the standby hydraulic system can power. That's your standby rudder, standby yaw damper, your leading edge devices to the extended position only, and your thrust reversers. Okay, now talk about our hydraulic system. Now I'm going to move over here to our flight control switches. These are your primary flight control switches. One for system A, system B. With the switch in the on position, it allows the respective hydraulic system to power those primary flight controls. Moving the switch to off closes that valve, preventing that respective hydraulic system's pressure and fluid to reach those primary flight controls. And then moving on up to standby rudder activates your standby hydraulic system to power your standby rudder PCU and the respective thrust reverser. Low pressure light comes on anytime there's a low pressure of hydraulic, low hydraulic pressure going to those primary flight controls from the respective system. That light is deactivated when the switch is in standby rudder. All right, moving across here to the alternate